I'm going to do several problems in this video covering the central limit theorem for proportions. Make sure in the week 5 spreadsheet you're on that correct tab that says it's for proportions. And then I want to talk a little bit about this information here for both the population data you could enter and for the sample data. There's this middle cell which it asks if up here if the population proportion is given or not. And so, like in this first problem right here that I'm going to look at, they actually tell us a population proportion. The proportion of adults in the United States who say they are financially ready for retirement is 31%. And so I have a population information. I don't know the size of the population. I don't know, I have like a count of the number of people out of the population who are ready for retirement. I just have a population proportion. So I would type in 0.31 here. And notice that when I do that, I don't know if I can squeeze it all in here. That's what pops up here as the population proportion. And these other two boxes here for population don't affect anything. They're kind of canceled out because I have a value here in the middle. If I type in no instead of using that value, it gets the ratio of these two numbers. So it's very important that you either type no in here if you don't have the population proportion, or you enter the proportion if it's given. And notice like when I type no, it's doing 800 out of 1,000 is 80% for the population proportion. Okay, the same thing is going to be true down here with the sample. You'll always have a sample size, and in this case, it says a random sample size 85. So I'm going to put 85 in there. And then you'll have the number of successes from your sample. And if you don't have those two bits of information, you'll actually have the sample proportion. So again, you'll either write no in here and enter these values, or you'll type in the direct number in here. And those are the only data, that's the only data we have for this problem. That's all we need. We have the population proportion, we have the sample size. And this problem is just asking what's the standard deviation for the sampling distribution. And oh, I changed my number here. It was 31%. So 31% size 85, you can see the standard deviation is given as 0.05 when you round it. So looking at another one here, a credit card company surveys its customers. And it says there are a total of 5,500 customers. So that's by population size. And 2,756 meet the criteria we are looking for here, which is use the card at least twice a month. And so we don't have a proportion given to us. It's going to be the ratio of the successes out of the total number there. So looking for the population proportion, I mean, that's already calculated, the ratio of those two numbers, population proportion. And then as well as the mean and standard deviation of the sampling distribution if the sample size was 70. So I'm coming down here to 70, and that's all I need to enter down here. I will now have the mean, which the mean is the same as the population proportion, and then the standard deviation has populated for us now for that sample size of 70. Rounding, that would be 0.06. Let's look at one more here. According to a study, 81% of pro gamers own a dedicated video game console. That's a statement about a population. So I'm going to type it in up here, 0.081. Once I have a value in here, again, these numbers don't really matter. I'm just going to leave them as they are. So 0.081 is our population proportion. And then at a gaming convention, 50 are sampled. So I'm typing 50 here. And then what's the probability that between 35 and 37 of them own a dedicated video game console? And so I'm going to need to type in 35 and 37 here and look at the calculations. I would much rather use that spreadsheet than try to do any calculation using an old-fashioned table like this. So I'm going to use the spreadsheet and just ignore this table here. Need to type no in here. We don't have a sample proportion. Well, we're going to look at here first. Let me type in 35. So if I look at here, I need between 35 and 37. So that's more than 35 all the way up to 37. So the probability that it's more than 35, It's not 0.9761. Now I don't want everything more than 35. I want to cut off at 37. So out of that 97.61, let's see how much of that is over 37, is more than 37. And that's 0.8962. So the rest of it has to be in between 35 and 37. If 0.89 is more than 37 out of that total 0.97, the rest of it, and just doing subtraction here, 0.9761 minus 0.8962 gives you how much is in between 35 to 37. And so rounding at the 3 decimal spots, I would actually have 0.080. And the other bit of information this problem asked for was the standard deviation. And rounding that to 3 decimals, it looked like it would be 0.056. And so I will caution you to be careful if this is already showing, like the last digit here is what you would use to round. Make sure it hasn't already rounded in Excel. So I'm going to click up here to add more decimals right up here. And so you see this is really 0.0554. So it would actually round to 0.055, which is the answer they were looking for.